Good morning everybody. This is Dr. Sekhar Chandra, chemistry teacher. Welcome to CEI. Today I'll teach a new chapter, new topics, that is in class 10, acid, bases and salts. I repeat, today I'll teach acids, bases and salts which are included in class 10 syllabus, icse. Now acid, bases and salts. Acid, bases and salts. Today I'll teach acids. Now definition. How will you define or what is the definition of acids? Now, according to Arrhenius theory, acids are the substances which can produce H plus ion or hydronium ion, H3O plus, when they dissolve in water. I repeat, according to Arrhenius theory, acids are the substances when dissolved in water producing H plus ion or H3O plus ion. H plus ion means hydrogen ion or proton, and or H3O plus oxonium ion or hydronium ion. So as for example, if I take HCl, it produces H plus ion plus Cl minus. Now since H plus ion is responsible for acidic nature, so HCl is acid. According to definition of Arrhenius, it produces H plus ion when it dissolves in water. Or we can write this way also, HCl plus water, H3O plus Cl minus. So let me conclude. According to Arrhenius theory, acids are the substances which will produce H plus ion or H3O plus ion when they dissolve in water. Now next definition by Bronsted-Lowry theory. According to Bronsted-Lowry theory, acids are proton donors. Acids are proton donor. Proton means H plus ion. So example, we can say NO3, H plus ion plus NO3 minus ion. Proton donor, or H2SO4, 2H plus plus SO4, 2 minus. So they are proton donor. I repeat that according to Bronsted-Lowry theory, acids are proton donor. Now third definition or third definition of acids, this is called Lewis theory. What is that? According to Lewis theory, acids are the substances which have vacant orbital to accommodate a pair of electron or lone pair of electron from an electron rich molecule. From an electron rich molecule, that means where the rich molecule should contain excess pair of electron or lone pair of electron. I repeat that Lewis acids are the acids which have a vacant orbital or vacant room to accommodate a lone pair of electron from an electron rich molecule or electron rich substances. As for example, for the Lewis acids are BF3, BCl3, LCl3, FeCl3, H plus ion, etc. They are all Lewis acids because they have vacant orbital. How can I explain the vacant orbital? Suppose BCl3, Cl and Cl. Boron has, you know, that 3 electrons in the outermost shell and they form with the 3 chlorine atom by combining covalent bond. So they have total number of electrons 6 and 2 electrons are less. So they have the vacant orbital to accommodate this to make it octet. It needs 2 more electron or a lone pair of electron so that it can form octet. So when it gets a pair of electron from an electron rich molecule, then it will be octet. So BCl3 is a vacant room, and this room can accommodate, or vacant orbital, it can accommodate a pair of electron to get octet. So BCl3, similarly BF3, ALC, all have the same explanation. Why are they Lewis acid? Because they have vacant orbital, and this vacant orbital are able to accommodate a pair of electron. So they are called Lewis acids. Now, definition of acids I have discussed. Let me repeat. There are three methods. There are three definitions of there. One is first one is Arrhenius theory. According to Arrhenius theory, acids are the substances which are able to produce H plus ion or H2O plus ion when they dissolve in water. Second is according to Bronsted-Lowry theory. According to this theory, acids are proton donors. And finally, Lewis theory, which is called the acids which follow the Lewis theory is called Lewis acids. So Lewis acids are the acids which have a vacant room or vacant orbital, which can accommodate a pair of electron from an electron-rich substances or from an electron-rich molecule, so that this vacant orbital will be completed by a pair of electrons, so that the central atom becomes octet. As for example, I have shown here BCl3 or BF3. Boron, it has 6 electrons in the outermost shell, outermost orbit, or boron trifluoride, it has 6 electrons outermost orbit, or AlCl3 also similarly, aluminum has 6 electrons outermost orbit. So they need a pair of electron. They need a pair of electron to get octet to become very stable. So they are Lewis acids because they are able to accommodate a pair of electron to make octet. Okay. Then definition is over. Now acids there are two types: strong acids and weak acids. Strong acids are weak acid. Strong acids. What are strong acids? Strong acids are the acids which are completely ionized in the respective ions. That means sulfuric acid, if you say it is a strong acid, nitric acid is a strong acid, HCl is a strong acid. Why the strong? Because they are completely ionized into their respective ions to form 2H plus and SO4 2 minus. Similarly, H plus ion, they are completely ionized to form H plus ion and nitrate ion, similarly H plus ion and chloride ion for the HCl. I repeat, they are the strong acids because they are completely ionized in the respective ions, so they are called strong acids. What about weak acids? Weak acids are the acids which are partially ionized, not completely. Because if you say we have 100 molecules of weak acids, then only few of them, like 10 or 15 or 5 molecules are ionized, so they are weak acids. As for example, acetic acid, most common examples of acetic acid is partially ionized into the respective ions, that is acetate ion and H plus ion. Similarly, if we say sulfurous acid, H2SO3 is also weak acid, it partially ionized into. They are the weak acids because they are partially ionized into their respective ions, not completely ionized like the previous strong acids. So let me conclude that weak acids are the acids which are partially ionized in the respective ions, so they are weak, and the examples are acetic acid, sulfuric acid. There are many. Actually, strong acids are only 3 of them are there. There is, according to syllabus, there is nitric acid, sulfuric acid, and hydrochloric acid, and remaining all other acids are the weak acids. So there are 2 types of acids I have discussed: weak and strong. Next is basicity of an acid. Basicity of an acid. What is that? Basicity of an acid is the number of replaceable hydrogen atoms present in it. That means when any acids are ionized, they produces H plus ion, and according to the number of H plus ion produced from an acid, it is called basicity. So basicity is nothing but the replaceable hydrogen atoms present in it. So I can say that basicity of an acid are the number of hydrogen atoms which are produced due to ionization of the acids. So there are various types of basicity, like monobasic acid, monobasic acid, dibasic acid, tribasic acid. Mainly there are three kinds of basicity. Monobasic acids are example HCl, HNO3, formic acid, acetic acid, etc. Though you know that formic acid there are two hydrogens are there. Formic acid there are two hydrogens are there. There are two hydrogens are there, but only one hydrogen is replaceable. This hydrogen is replaceable because the structure will be like that: COOH. This is the structure of formic acid. So this hydrogen will be the replaceable. So it is a monobasic acid. Similarly, acetic acid CH3, C double bond OOH. There are four hydrogens are there, but only one hydrogen is replaceable. So it is a monobasic acid. I repeat, though HCl, HNO3, they have only one hydrogen. No question arises about the basicity because they are monobasic acid. But in case of formic acid and acetic acid, there are more than one hydrogen atoms are present. But which of them are acidic? They are only one hydrogen is acidic for in case of formic acid. Acetic acid also there are only one hydrogen is acidic because these three hydrogens are not acidic in nature. This hydrogen is not acidic in nature. Only those hydrogen which are bonded with the electronegative atom oxygen, they are only acidic. So they are monobasic acid, though they have more than one hydrogen atom. Okay, dibasic acid example, you know, sulfuric acid is the most common example. Sulfuric acid, all of you know. H2SO4 because there are two hydrogen replaceable, or oxalic acid COOH. These two hydrogen are replaceable, so they are dibasic acid. Tribasic acid, you know, H3PO4. This is a tribasic acid because they have the three replaceable hydrogen atom. So we give an example: monobasic acid, dibasic acid, tribasic acid. And this basically depends on the number of replaceable hydrogen, not the hydrogen atoms present in a molecule of an acid. It depends only the number of hydrogen which can be replaced, which are replaceable. That hydrogen are acidic in nature. So basicity of an acid I have discussed. Next part will be the preparation of acids. Preparation of acids. Preparation of acid. First method by direct union. Like you know that's H2 plus F2, 2HF, hydrofluoric acid, H2 plus Cl2, 2HCl, H2 plus Br2, 2HBr, etc. That means by the direct union of hydrogen with the halogen, hydrogen plus fluorine, hydrofluoric acid, hydrogen fluoride gas, hydrogen plus fluorine, HCl, hydrogen fluoride gas, H2 plus Br2, HBr, hydrogen bromide gas. So the first method is by the direct union of hydrogen with the halogen. Second, by the action of water with acidic oxide. Because acidic oxides are non-metallic oxides. I have already explained the previous classes. Acidic oxides, non-metallic oxides like carbon dioxide plus water, we get carbonic acid. Sulfur dioxide plus water, sulfurous acid, sulfur trioxide plus water, sulfuric acid, nitrogen pentoxide plus water, nitric acid, phosphorus pentoxide plus water, phosphoric acid, and very important example, that is nitrogen dioxide plus water. We get a mixture of two acids. I have discussed already previous classes, nitrous acid and nitric acid. Mixture of nitrous acid and nitric acid, because NO2 is called mixed anhydride because it produces a mixture of two acids, that is nitrous acid and nitric acid. So this is the second method of preparation of acids What is the method? Method is by the direct union, by passing the acidic oxide, by passing the non-metal oxides to the water. When they dissolve in water to form the respective acids like carbonic acid, sulfuric acid, and so on. Third method is by using non-volatile acid to produce more volatile acid. Number 3, by using non-volatile acids, non-volatile acid to produce more volatile acid, to produce more volatile acids. What is that? Suppose NaCl plus sulfuric acid to produce sodium sulfate. If you heat sodium sulfate plus 2HCl, it is less volatile, it is more volatile. It is less, it is more. Suppose NaNO3 plus sulfuric acid, we get heat করলে we will get Na2SO4 plus HNO3. It is more volatile, it is less volatile. Similarly, sodium acetate CH3CONA plus sulfuric acid, heat you get sodium acetate, we get acetic acid plus sodium sulfate. This is more volatile, this is less volatile. This is less volatile. So let me conclude. By using less volatile acid, by using non-volatile or less volatile to create the more volatile acids. So here, by applying less volatile, we will get more volatile HCl. By applying less volatile, we will get more volatile HO3. By applying less volatile, we will get the more volatile acetic acid. This is the method from which we get acids. And the last method, that is number 4, from non-metallic oxides, from non-metals, How is that? When sulfur is heated with concentrated nitric acid, we get sulfuric acid plus NO2, nitrogen dioxide, plus 2, that means 2 water. Concentrated nitric acid. So then we can, another reaction is P plus 5HNO3, we get H3PO4, another acid, plus 5NO2 plus 6, that means here 1 water. Okay, or P plus 5H2SO4, we get H3PO4 plus 5SO2 plus 2 water. Okay, 10, then 6 or 4, 2 water. Now, let me conclude that when constant nitric acid is treated with sulfur, we get sulfuric acid, preparation of sulfuric acid by using nitric acid. When phosphorus is treated with concentrated nitric acid, this is concentrated, we get phosphoric acid. Here also concentrated. When sulfuric acid is used, we get the phosphoric acid. By using concentrated acids, we are getting the another acids. When we apply non-metals like sulfur, phosphorus, iodine, etc. Iodine I have not given here, but I have given only the sulfur and phosphorus. So let me conclude that we are defining the different methods, different definition for the acids, then different types of acids, then basicity of an acid.